Hello everybody. We are going to go over the problems in practice midterm. And to start with, we first look at number 2. So it is implicit function of y in terms of x. And we want to compute dy dx at the point -1, 0. And this problem can be a good question in Calc 1, but here I'm going to provide the way we did in Calc 4. So to solve this problem, we first recall that if you have fxy, right, equals some constant c, then we can take the differential both sides, and constant does not change always, so differential of constant is 0, but this differential is basically total differential is fx dx plus fy dy equals 0 and dy. And then we can solve from here dy dx as negative fx fy. So eventually we want to use this formula. If you do not understand these first three lines derivation, then you can just memorize this one to solve this problem. So for the problem to compute dy dx, we need fx and fy, two quantities, and then just take the ratio. So what is fx? Fx is going to be, so here obviously our choice for fxy is this. So this is our, so we set fxy as the left hand side, whatever it is. So we just copy that, and then we take the partial derivative. So 6x cubed minus y to the 4th power 5th, and x derivative is 3x squared plus 1 over x squared plus 1, chain rule again, and x derivative is 2x. And we put actual numbers, then this is 6 times -1 times -3, not negative, positive 3, because x squared, plus this is 1 times -2, so this is -2, the last one, and that gives me -20. And fy, so again chain rule for the first term is, we're looking at this, so 6 times this to the power 1 less, which is 5, and then y derivative is this is 4th power, y derivative is -4y cubed plus x squared plus y, and y derivative is 1, and I want to put -1 0 here. So when I put -1 here, this is -1, but here is 0. 0 multiplied by anything is 0, so the first term is just totally disappeared. And second term here is 1 plus 0, so basically it is 1. So this is 1. And dy dx is negative of fx divided by 1, which is fy, which is 20. All right. Now we're looking at number 3 now. So the function is given by a function of 3 variables, and the graph is 4-dimensional. So this is given by here, and the target position is 0, pi over 2, 0, which stands for x, y, z. Now we want to find gradient f, which means fx, fy, fz, and find tangent plane and normal line. All right. First question is gradient f. So gradient f is nothing but for 3 variables, then this is fx, fy, fz. So it's basically equivalent to asking 3 questions. What is fx? Then this term has nothing to do with x. So derivative of with respect to x is 0. So e to the x derivative is e to the x. And if you plug in p0, which means x is 0, so e to the 0, 1. What is fy? For y derivative, this becomes 0. And for this, we need to use change rule. And for this y derivative, this is 1, so it's basically 1. And if I put p0, then this is negative sine pi over 2, which is negative 1. fz is similar, negative sine y plus z, and p0. And yes, this is negative 1 here. So we can write gradient f p0 as 1, negative 1, negative 1. It's a vector of 3 element, or 3D vector. Now the next question is, what is tangent line? So, and normal line. We know that tangent line, a tangent plane, right? For it's not line because 3 variables. Tangent plane is orthogonal or perpendicular to the normal line, which is gradient. So we can write this. TP, tangent plane, is orthogonal to gradient fp0, and normal line is parallel to gradient fp0. So if you know this this behavior, then we can write the equation along this. So we know that if we want to characterize something orthogonal to something, then its inner product is 0. So we have 1, negative 1, negative 1, which is gradient f. And x minus x0, y minus y0, z minus z0 equals 0. This is for tangent plane. Here x0, y0, z0s are given, so I'm going to replace that by 0, pi over 2, and 0. And the dot product, we can multiply this. This is x multiplied by this. This is negative y plus pi over 2. And this is negative z equals 0. So the equation is basically, so if you want, you can put the constant term to the other side. So this is the answer for tangent plane. And normal line, for normal line, we're going to use a parametric equation. So because normal line is going through P0 and in the direction of gradient f, so what you do is x equals x0 plus, in x direction the rate is 1, so this is 1 times t, and y0 plus, in y direction -1 is the rate change, and z direction we're changing still -1t. So actual number for x0 is 0 and 1 times t. Y equals pi over 2, which is given as p0 and minus t, and z equals 0 minus t. So this is normal line. All right. So we had 2 and 3. Now the next thing is we have function of two variables, and at target point find the direction in which f is increasing most rapidly. In other words, you want to move in the direction to the gradient that gives you increasing most rapidly. If you go opposite, then it decreasing most rapidly. So we want to find the direction which increase most rapidly. In other words, you want to find gradient and normalize it, because direction, a vector, to be a direction, you have to normalize to the unit length. So we still want to find gradient f, which is fx, fy. It's 2D vector because there are two independent variables. And this is 3x squared plus 3y. And fy is 3x plus 3y squared. And I want to put p0. P0 is given by -1, 1, -1, 1, -1. So first one is 3 minus 3. 3 plus 3, this is 6. And this is not direction because the length of this vector is just 6. So you need to normalize that, which means gradient f, by normalizing, means its length. Then this is 0, 6, and gradient f, its length is square root of 0 squared plus 6 squared, which is 1 over 6. So 1 over 6 and 0, 6, and this is 0, 1. So this is direction. So our answer is f is increasing most rapidly in direction u, 0, 1. Consider two-variable function. Find direction derivative at given point in the direction of v equals 3i plus 4j. Here the trap is v is not directly given as a direction. It has length 5 because 3 squared plus 4 squared is 25. So here, the formula for direction derivative is, so first of all, I want to write down a normalized v, which is, so let's say u is its direction, then which is normalized by its length. And what is its length? I first copy the whatever v is, and this is, sometimes I write this 3i plus 4j as 3, 4. They are the same symbols, notations, and its denominator is its length, magnitude, which is 5, right? So 3, 5i plus 4 over 5j. So this is u. Then the formula for direction derivative in this case is, this is notation, but we often write this as gradient f dot product u and plug in numbers. You can plug in numbers first sometimes, so it may be easier. So if you want it, you can write this in this way. So what I mean is gradient f and put p0, then you get the number, two numbers for 2D vector, and then dot product u. And here gradient f means fx, fy, p0, dot u means 3/5 and 4/5. And what is fx? So for here, when I take derivative with respect to x, this goes 0, negative y e to the x. Negative y e to the x, and fy, then ey minus e to the x. Ey minus e to the x. And p0 is 1, 0. So we are going to put 1, 0 here. And later we multiply two numbers as dot product. Then this guy is, if I put, of course, if y is 0, then the whole thing is 0. So this is 0. And e to the 0, which is 1, minus e to the first power, which is e, and 3/5, 4/5. So 0 times 3/5 is 0. This is 1 minus e, and then 4 over 5. All right, this is the number 5, and now we go back to limit problem. So for the limit problem, always we want to try substitution method. In other words, replace x by 2 and replace y by 0. But then it doesn't give you directly the answer or it is useless very often, because if it works, then it's too easy to be a quotient in midterm exam. So, but nevertheless, we are going to use substitution. So 2 times 2 minus 0 minus 2, 2 times 2 minus 0 minus 4, this is 0 over 0. So this means 2 more. So our solution in this case, we're going to simplify if it's possible. So for this problem, it is possible because we want to rationalize the numerator. So by rationalizing, I mean we can use, so we can use difference of squares formula. And in the denominator, I just copied, but I need to multiply the same thing so that we didn't change the original function. So the original function is here. Now what I did is I multiplied by 1 something over itself. So I didn't change anything, but the nice thing about this is we can rationalize this. So a squared minus b squared is a minus b times a plus b. That's the formula we use. Then the first number square is 2x minus y. The second number square is 2 squared, which is 4, which is exactly the same as first factor of the denominator, and second factor is here. So if I cancel this out, then we have simplified form, which is enough to do substitution. So when I put 2, 0 here, then this becomes 1, 2 times 2 minus 0 plus 2, which is 1 over 4. The next one is again limit problem, but a different type of limit problem. So this is 1b. So for here, substitution obviously gives 0 over 0, so useless. But then we try to simplify this function, but there's no obvious way we can simplify that. So now we're going to try to prove the limit does not exist by using two-path test. So usually by two-path test, we're going to give a curve which is going to the target point 0, 0. So at least two curves. So those things we want to construct is parameterized. So x equals from x0 is 0 here, times t. So if you change x from the target point 0 to a little bit t, then y is also going to change it. So we are going to change it to pt. P is some given number. So if different p, then this gives different lines. So with slope p, this is parameterized equation. And we want, so here p is given constant, and t goes 0. T must go 0 because only if t goes 0, then x and y both go 0, which satisfies this limit to the target point. So if we give p as 1, then this is a line with slope 1. If p equals 2, then this is a line of slope 2. Now we look at, under this setup, along this curve, I want to look at the function itself, which is negative t and t squared plus p squared t squared. Now we can, obviously we have t squared as common factor which can be taken out, but we have to be very careful when we take t squared from square root. It's not t. T could be negative, but only if t is positive, then you can take out without absolute value. So when so we want to try to make it t goes to 0 plus. In other words, t is going to 0 from positive side. So which makes sure t is positive number. So when I do this, we can take out t without absolute value. And then t and t cancel, which is negative 1, 1 square root of 1 plus p squared. This tells us there's no limit because the answer, the limit along this p path is p dependent. So different p stands for different curves, different path. And for along different p path, you have different numbers. So that means by two path test, because is p dependent, there is no limit exists. All right, that's pretty much everything. And sometimes when you do the two-path test, this is not sufficient because sometimes no matter what p is, at the end you are going to p independent limit. Then in that case, if you truly believe there is no limit, then you should try different p path, not necessarily linear. For something like, you can try x equals 0 plus t squared, y equals 0 plus pt, or maybe opposite way. So you can change those powers to find different limit. All right, we're going to stop here.